C++ arrays.
Now here we are having one integer array having the name n with 10 consecutive locations, and here the subscript or the location number will be ranging from 0 to 9. So we are executing one for loop, and the for loop is extending from 0 to 9. So int I is equal to 0, I less than 10, so I can get up to 9 only, and I plus plus I will be incremented by 1 always. Ni, that is at the ith location of the n array, I plus 100. So the value of I will be at first will be 0. So 0 plus 100, 100 will be assigned. 1 plus 100, then 101 will be assigned. 2 plus 100, then 102 will be assigned. In this way, the values will be assigned accordingly. Set element at location I with I plus 100. So now here we are printing headings, that is the element and value. So if we compile our program, and if I want to show you that how the outputs are coming. So now here you see the element is the respective text. This is a respective text we are having element, and set with 13 we are having this set with 13 characters, and then value, and then endl. So here we are having 13 characters, out of them value is having 5 characters. So here in between we are having 8 characters gap, so that we are having this output in a very columnar way. So for int j is equal to 0, j less than 10, j plus plus, so again the j is ranging from 0 to 9. So cout set with 7, and then we are printing this value j. So here you see we are having this 7 is the width, and then 0 to 9 they are the single digit numbers. So as a result of that we are having 6 blank spaces beforehand, and then numbers are getting printed. And then set 13, again we are denoting, we are having this set with 13 characters, and out of them 3 of them are getting occupied by the 3 digits, so 10 blank spaces beforehand, so they are coming. So set with 13, and nj, we are printing this current value of this n array at the jth location, and endl will bring the next line, printing in the next line. So in this way this particular array is getting defined, array has got initialized, then array content is getting printed. So in this way we have explained this program line by line. I think now your conception is getting clear at this particular stage.
C++ relational operators.
We are going to execute our code, and we shall explain the output line by line. So here we have done the compilation and run. So here we are using depc++ for the execution of our code. So this is the respective output. So a is equal to 21, b is equal to 10, and c is defined but uninitialized. So a is equal to b is false. So that's why the control will be coming to the else part, and line 1 a is not equal to b. So line 1 a is not equal to b has got printed. Now a less than b, a is equal to 21 and b is equal to 10, so a less than b is false. So the control will be coming to this else part. So line 2, a is not less than b, a is not less than b, so a is not less than b. So the corresponding output has been explained logically. So now if you go for the next part, that means a greater than b, and here it is true because 21 is greater than 10. So line 3, a is greater than b is going to be printed. So line 3, a is greater than b has got printed. So now here we are having a is equal to 5 and b is equal to 20. So now if I go on printing, a is equal to 5 and b is equal to 20. So if a less than equal to b, so a less than equal to b is true. So line 4, a is less than or equal to b. So line 4, a is less than or equal to b. And b is greater than equal to a. Line 5, b is greater than or equal to a. So b is greater than or equal to a. In this way, we are getting this output logically explained.
C++ logical operators.
Now let us explain this program with the execution. Here value of a is non-zero, that is 5, and b is also non-zero, that is 20, and c is uninitialized. So a and b, here we are doing this particular logical operation. So here is a logical operator AND. So a and b, here we are getting the line 1, the condition is true, because here a is non-zero and b is also non-zero. So now non-zero means both are true. So true and true will be true. So the condition is getting satisfied and the output is obtained. So let me execute the code at first so that we can have the better understanding. So let us execute the code in GNU++. So we are having this compiler G++, and then our program name is this one -o. The output file will be say a.exe. So after compilation, if I execute, I'm getting line 1 condition is true. So really I'm getting this line 1 condition is true. A or B, here both A and B are non-zero, so both are true. So true or true will be output will be true. So line 2 condition is true is getting executed. So now A is equal to 0 and B is equal to 10. So A and B will be returning the value 0 here or false here, because 0 means false and non-zero means true. So false and true output will be false. So condition will be going, the control will be going to the else part. So line 4 condition is not true. So line 4 condition is not true. So the output is coming accordingly. And if you take the negation over it, so if we do the complement of that, then we are getting line 5 condition is true. So line 5 condition is true is coming accordingly. So if we do the compilation and if we do the execution in DepC++, we are supposed to get the same output. Really, we are going to get the same output as we got in case of GNU C++ program compilation output. So in this way, the program has been explained.
C++ bitwise operators.
Let us explain this program and also to show you that how the bitwise operation can be done in C++. So here this value of A is equal to 60. In binary it has been expressed in this way. Value of B is equal to 13. So in binary it has been expressed in this way. And C is equal to 0. Okay. Now A and B. So that means I shall be doing the bitwise ANDing. We know that 1 and 1 is 1 and 1 and 0 or 0 and 1 or 0 and 0 will produce output 0. So if you do this bitwise ANDing, I'm getting this 1 1 will survive and all other rest bits are getting ANDed with either one of the zeros will be there. So as a result of that, the output will be like this, which is nothing but 12. So if you print the value of C here, so I'll be getting 12 here. So in case of odding, the output will be like this one. The decimal equivalent is 61. So accordingly, it will get printed. So 61 is supposed to get printed here. Okay. Now here we are having the respective values, that is A XOR B. So A XOR B means we know that 0 and 1 and 1 and 0, their XOR will be 1. Zeros are 0 and ones are 1, the XOR will be 0 in that case. So similarly, if we do this XORing, so XOR will be denoted by this particular upper caret symbol. So there is a representation of XOR. Okay. Now, so if you do the XORing between this A and B, so then the output will be obtained as like this one. So you just go on doing the XORing, we will be getting this output like this, and that will be 49. So 49 is supposed to get printed here. So here we are doing this complement. Complement means ones complement. So 0011 1100 will be converted to 1100 and 0011, and which is nothing but minus 61, because here this one will indicate the number is negative and the respective value will be obtained by taking the 2's complement of that. So it is minus 61. So value will be minus 61. So line 4, the value of C is this. So let me execute the code also side by side. So here we are getting this, that is C is equal to minus 61. Okay. Now next one is A. There is a double arrow. This particular double less than symbol will indicate that we are moving this A. All the bits in A will be shifted towards the left hand side. So left shift will take place for 2 bits position. So ultimately we are getting this value, and this value is nothing but 240. And here we are doing this right shift for 2 places, so here is the respective value whatever we are going to obtain. So if we do the left shift for 2 places, then in that case 2 bit positions, then in that case these 2 zeros will disappear. And if we do the right shift for 2 places, 2 bit places, then these 2 zeros will be disappearing, and the free space will be filled up with zeros. So as we did here, so it is nothing but 15. So similarly, we are getting this output like this. Now let me execute the same code. Now let us execute the same code in our GNU. So G++, program name is prog16.cpp, -o a.exe will be the output file name. So if I execute the code now, after compilation, we're getting the same output which we obtained in case of depC++ output. So in this way, we have explained the execution of this program, and this program is dealing with different types of bitwise operators.
C++ assignment operators.
Let us explain the execution of this program now. Here we are having this int a is equal to 21, int c which is uninitialized, c is equal to a. So let me execute my code so that we can get the idea that how the outputs are obtaining. So I'm executing my code now. So this is the output screen we are getting. So also I'm putting this notepad side by side to do any rough work. Okay, int a is equal to 21 and c is defined but uninitialized. C is equal to a and the value of c has got printed. So c has got printed as 21. C is plus equal to a, that means c is equal to c plus a. So c is having value 21, a is having value 21. So 21 plus 21, 42 will be the new content for c, and that has got printed here. Now c minus equal to a, so 42 minus 21. So c is equal to c minus a, so 42 minus 21, so 21 will be the new value for c. So 21 is coming for the new value for c. Now c star equal to a, so now c is having the value 21 and a is also having the value 21. So 21 into 21, the multiplication is taking place, and that is 441. So in this way you are getting this 441. So now c slash equal to a, that means c is equal to c by a. So that means 21 squared by 21. So that is 441 by 21 is equal to 21 will be the new value for c, and yes, the value of c has got printed as 21. Now c is equal to 200 and c percentage a, percentage is equal to a, that means c is equal to c percentage a. That means the value of 21, this particular value 200 rather, will be divided by 21, and the remainder whatever is getting obtained, and that will be assigned to c. So the value of c has become 11 in that case after doing this remainder operation. So c, there is a left shift equal to 2. So that means that we are going to shift the value of c towards the left hand side for 2 bits place. So we know that 2 bits place left shift means 2 to the power of 2, that is 4 will be multiplied in the resultant value for c. So 11 into 4, so the output will be 44 in that case. So now again we are doing the right shift for 2 places, and as we are doing the right shift for 2 bit places, so that 44 has to be divided by 2 to the power of 2, and that is 2 to the power of 2 means 4. So again we are getting back this 11. Now c and 2, so 11 means we know that if you write 11 in byte form, and that is 8, 4, 1, 2 and 1. So it is 11 is nothing but 8 plus 2 plus 1. So that's why I have placed 8, that means 1 I have placed in the position of 8. So 0 I have placed in the position of 4, and in the position of 2 and 1 I have placed 1 and 1. So now if it is getting ended with the value of 2, so that is 0010, then I'm going to get, after doing this ending, I shall be getting this 2 as a result, so which is nothing but 2. So that's why after doing this AND operation we are getting this 2, and then we are doing this XORing with 2. So we are doing this XORing, so 2 XOR 2, always it will be 0, because similar bits XOR will produce the output 0 in that case. So if we do the XORing between these two, if we do the XOR, then obviously the output will be 0. So similarly I'm getting this value c is equal to 0, and in the last we are doing this ORing with 2. So with this result, if we do the ORing, then obviously the output will be 2 again. So in this way the output has become 2. So in this way we have explained that how the outputs are coming, and the same outputs will be obtained in case of GNU++ if you go on compiling our program in GNU++. So in this way we have explained our code with the proper tracing, that how the values are getting generated.